Let's do some physics. So, if you're taking physics right now, you are taking algebra based physics. Um, Now we're doing calculus based physics. And when you go to college, that's kind of the difference between, you might see it called, general physics or college physics and university physics. The difference will be, is it based on algebra or is it based on calculus? And now you're ready for either one. Let's do this. A rock is thrown upward with an initial velocity, v of t, of 18 meters per second. Let's pause right there. I wanted to mention something about that initial velocity. What that's telling you, that's telling you that when t equals 0, that's telling you what v of t is. It's telling you that it's 18 meters per second. You might see a problem that says initially the object was at rest. If it says at rest, that's telling you that v of t is 0. From a height, h of t, of 45 meters, so again, that's at t equals 0. We're still on the initial. The initial height is 45 meters. So h of 0 is 45 meters. And height, it's a position, right? It's not x of t or s of t, it's just h of t. It's all the same thing. If the acceleration of the rock is a constant 9 meters per second squared, so we have our equation for a of t, negative 9 meters per second squared. I'm going to leave the units off of that. Find the height of the rock at time t equals 4. So what I need to do is I need an equation for h of t. So I'm going to start integrating. I know that if I integrate the acceleration equation, that's going to give me v of t. And so that's just negative 9t plus c. And then it's these initial conditions here that let you figure out what c is. If I plug 0 in for t and 18 in for v of t, that gives me that c is equal to 18. So I've got a nice equation now that v of t is equal to negative 9t plus 18. If I integrate that, that'll give me h of t. So I'm going to integrate both sides of that. So I've got that h of t is equal to negative 9t squared over 2 plus 18t plus c. And then again, I'll use that initial condition right here to find out what c is. If I plug in 0, 0, and 45 here, that gives me that c is equal to 45. And so I have everything I need now to figure out what h of 4 is. I can say h of 4 is negative 9 times 4 squared over 2 plus 18 times 4 plus c was 45. And I already typed that all in the calculator because I didn't want to mess with it. That comes out to be 45. If we have units, we should probably use them. Yeah, we're looking at height in meters, so let's go ahead and put meters on that. Okay, so those problems are not too bad. The moral of the story on those is you can get from acceleration to velocity to position by integrating. Every time you integrate, you've got to go back to the problem and find a data point to figure out what c is. And then you can solve for anything at any time with any of those equations. Oh, these problems are good. Let's do this one. An object moves according to the equation, blah, blah, blah. Find the displacement of the object for the first 3 seconds. And then part B, we're going to find the total distance traveled. And I hope you understood the difference there between displacement and the total distance traveled, right? If, an object goes 5 meters and then comes back to its starting position, the displacement is just the final position minus the initial position. So if it goes and comes back, it can have a displacement of 0. The total distance, that's more like, the odometer in your car. You went 5 meters, you came 5 meters back, that was a total distance traveled of 10 meters. In terms of calculus, what that means for us, to find the displacement, all we have to do is integrate the velocity function. For the total distance, we have to integrate the absolute value of the velocity function. And integrating absolute value, there's not a clear way to do that. What we have to do is we have to figure out where the object changes direction and actually split up the integral, solve each piece of the integral separately. There's no way to do that. You can do it, numerically, but algebraically there's no way to do those absolute values. So let's go back. Let's actually solve this problem here. Clear all that away. So find the displacement for the first 3 seconds. So I'm going to integrate 5t minus 7 dt. And I'm going to integrate that for the first 3 seconds. So from 0 to 3. So I get 5t squared over 2 minus 7t. Evaluate that from 0 to 3. And I kind of already did the arithmetic because that's not the important part of this problem here. And we get 3 over 2. We could get a negative number here. That would tell us that the object had a net movement to the left. Positive number here means it had a net movement to the right. That is okay. So now for part B, we want to find the total distance traveled. That means I have to figure out where, if anywhere, does this object turn around. If the object never changes direction, then the total distance is the displacement. You know, you just go 3 over 2 and you're done. But let's see if this changes direction. So I have to find out where is v of t, which was 5t minus 7. I want to know where is that equal to 0. That was easy. T is 7 over 5. That's in my range between, what was it, 0 and 3 seconds, so that's fine. And then we can check real quick to make sure. Remember, it doesn't change directions unless the acceleration is non-zero. So real quick, I can take the derivative of v of t and see that the acceleration is going to be 5. Doesn't matter what time you're at. That's definitely not equal to 0. So I feel good now that the particle does in fact change directions. If the acceleration is 0, that means your particle has just come to a stop and it's going to keep going in the same direction. Then you wouldn't have to mess with all this. The displacement would be equal to the distance traveled. But it does change directions, so this tells me where to split up my integral. So what I'm going to do is I'm going to integrate from 0 to 7 over 5 v of t. I'm going to take the absolute value of whatever answer I get. I'm just going to make it positive. And I'm going to add that to the integral from 7/5 to 3 of v of t. I'm going to take the absolute value of that. That is how we will take the integral of the absolute value of velocity. So we take the absolute value of each individual piece using this as our dividing point. Okay, so if I do this here, I get, for that first integral, so I've got 5t squared over 2 minus 7t, and I evaluate that from 0 to 7/5. And then for the second integral, I've got the same thing, 5t squared over 2 minus 7t, evaluated from 7/5 to 3. So again, I'm going to take those two absolute value, add them together. I already did this arithmetic. If you plug 7/5 in, you get negative 49 over 10. If you plug 0 in, you get 0. So that gives me negative 49 over 10. But I'm going to take the absolute value of that. So it's going to be positive. Over here on the right, if you plug 3 in, you get 3 over 2. We already saw that. And if you plug 7/5 in, you get negative 49 over 10. Get a common denominator there. You're going to get 32 over 5. And then common denominator here, we have 64 over 10. So this was already positive, but I did take the absolute value of it. And so now I'm adding these two together for a grand total of 113 over 10. Whew. They're kind of tedious and they're repetitive, but they are doable problems.